Hi guys, so I just kind of wanted to give you guys kind of like a video definition of the parts of the parabola. So as we look here, let me get my pen so that I can write on this. As we look at here, we have corresponding points. So what corresponding points are points that are equal distance from the axis of symmetry. So the axis of symmetry, which we'll talk about, is right here. It is literally the line that cuts my parabola in half perfectly. So our corresponding points that correspond to each other, are reflective. Basically, if I were to fold this parabola back, they would end up perfectly aligned to this side. And so they are even distance from the axis of symmetry. So for example, if we look at our corresponding point here, if we look at our corresponding lines here, we can see that we got about the same distance from both points. We have about 1, 2, 3 and a half points of distance. So that is what our corresponding points are. The axis of symmetry, as I had said, is that line that cuts that parabola perfectly in half. Then we have our y-intercept. So our y-intercept is wherever our parabola touches my y-intercept. And it is always 0 on my x-axis. So for example, here, we look at our y-intercept right here. It's a -1, and we could see that our x, if we look at our x, is going to be 0. So our y is always going to be a number, and our x is always going to be 0. It is where our point touches our y-intercept. Now, the opposite of our y-intercept are solutions, because it's the x. So solutions have a couple of different names. You can call them solutions, zeros, roots, x-intercepts. And the SAT loves to switch it up. They love to call it different things. So you really need to understand what do they mean by when you're talking solutions, zeros, roots, and x-intercepts. So that is basically the solutions of my parabola. What they mean by that is where they touch my x-axis, right? So the 2 points that touch my x-axis right here are this -4.5 and this about half. So those are going to be my solutions. In this case, our y is 0. So because it's touching our x, it's in that point, but in our y-intercept, it is 0. So that is basically where our x-intercepts are. Then we're going to go into our vertex. So our vertex is the middle of our parabola. Our vertex is also going to help us determine if our parabola has a maximum or a minimum. So for example, here, we could see that my vertex on the y-intercept is a -3. And usually when we talk about our vertex, we usually care about our y-intercept. So our y-intercept here is our -3, which means that my axis of symmetry is -3. Now, how do we figure out, Ms. Gonzalez, if I have a maximum or a minimum? Easy. If we look at our parabola, it looks like a smile. It is smiling, kind of like this. So if it is smiling, I have a minimum. Why do I have a minimum, Ms. Gonzalez? If I'm smiling, I'm happy. I should have a maximum. No. So you have a minimum because this is the smallest number on your y-intercept that it is going to be, right? If we look here, my y, I am just going up from here. All my numbers are going to be bigger than that -3. Am I ever going to touch anything below that -3? No, I'm never going to touch anything below that -3, which is why that is our minimum. That's going to be the minimum vertex, the minimum y-intercept my parabola is going to touch. Now, let's say we had the opposite. Let's say we had a maximum vertex. If we had a maximum vertex, our line would look something like, our parabola would look something like this. It would be a sad face. It'd be a sad face because if you look at right here, our vertex will be around right here, correct? If we look at our y-intercept, everything is going to go down from here. It's not going to be up. There's nothing up here. That is the maximum it's going to be on my y. Everything else is going down. So that is basically all our parts that we're going to use for our parabola.